In the last section, we talked about when two lines are cut by a transversal, different angle pairs are formed. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Now in this section, in 3.2, we're going to be dealing with the same angle pairs, but now there'll be a certain relationship between those angle pairs when the two lines that are cut by the transversal are parallel. That's why this section is called Parallel Lines and Transversals. We'll start this section with a postulate. Now remember, a postulate is something that we just know is true. It is not anything that we can prove is true. We know it's just true because it has to be true for this world to work like it does. So this is the corresponding angles postulate. It states if two parallel lines are cut by a transversal, so looking at this diagram, lines P and Q are parallel and they're marked as such, just like we saw last section on how you can mark that two lines are parallel, and they're cut by transversal T. Then the pairs of corresponding angles are congruent. So remember, corresponding angles means that if I put these two lines on top of each other, they're the angles that match up. So they're calling this angle 2 and angle 6. They would be sitting on top of each other if line P was put on top of line Q. So again, this is a postulate. It's just something that we know has to be true, that if two lines are parallel cut by a transversal, the corresponding angles have to be the same size. By just looking at these, they look like they're the same size. I know you can't prove things by looking at them, but they would just have to be true that the two angles would be congruent. So not just angle 2 and angle 6 would be congruent. This angle here would be congruent with this angle here. This angle here would be congruent with the angle down here, and this angle here would be congruent with the angle down here. All corresponding angle pairs would be congruent when the two lines cut by the transversal are parallel. Example number 1, given the diagram below, find the measure of all of the numbered angles. So they give us that this angle right here is 55 degrees. First, let's find the measure of angle 1. Notice that angle 1 and the 55-degree angle that we were given form a straight line. Therefore, I would find the measure of angle 1 by taking 180 minus 155. Therefore, the measure of angle 1 is 125 degrees. Notice I also wrote it in the diagram. You'll find it's easy to find all the different angle pair relationships when you write their measures on the diagram as you find them. So number 2 says find the measure of angle 3. We know that angle 3 is a vertical angle with the 55-degree angle that we were given. Vertical angles are congruent, so therefore the measure of angle 3 is 55 degrees. Number 3, measure of angle 4. Measure of angle 4 would be the same as the measure of angle 1 since they're vertical angles. So the measure of angle 1 was 125 degrees, so the measure of angle 4 is 125 degrees. Number 4, measure of angle 5. This time it's going to take a little bit more to figure out what the measure of angle 5 is. Notice that measure of angle 5 would be the same thing as the measure of angle 1 since they are corresponding angles. This line is parallel to this line because we were shown that with these little triangles here. So therefore, from the first postulate, we would know that corresponding angles are congruent. So if angle 1 is 125 degrees, angle 5 would be 125 degrees. Number 5, measure of angle 6. We can actually find the measure of angle 6 in a couple different ways. Measure of angle 6 would be the same as the measure of the 55-degree angle since it is a corresponding angle with angle 6. So it's 55 degrees. Or we also know that the measure of angle 6 plus the measure of angle 5 would have to be 180 since they form this straight line. So either way, I would get 55 degrees for the measure of angle 6. Number 6, measure of angle 7. We can find the measure of angle 7 in a couple different ways as well. We know that angle 7 is corresponding to angle 3. So if angle 3 is 55 degrees, so would angle 7. We also know that it is a vertical angle with angle 6. So if angle 6 is 55 degrees, so would angle 7. It is also a linear pair with angle 5 because they're forming this straight line. So they'd be supplementary. So it's still going to be 55 degrees. So no matter how you justify it, angle 7 is still 55 degrees. And number 7, the measure of angle 8. We have lots of different ways we can figure out the measure of angle 8. First off, we know that it is a corresponding angle with angle 4, so it would be 125 degrees. It's also a vertical angle with angle 5, so it would be 125 degrees since vertical angles are equal. It is also linear pairs with angle 6 and angle 7, so we would take 180 minus 55 and still get 125. And there you have it. We'll use this same diagram in the next slide to start coming up with more conclusions about alternate interior angles, alternate exterior angles, and consecutive interior angles Again, these are angle pairs that we talked about in the last section. So here again is the diagram from the previous example. Let's look at all the different angle pairs that we learned in the last section to see if we can make any conclusions. So again, we already know from the first postulate from the section that corresponding angles are congruent. Now let's look at how alternate interior angles are related. So remember, alternate interior angles are angles on the inside of the two lines that are being cut by the transversal, and they are on different sides of the transversal. So if you notice here, 3 and 6 would be alternate interior, and 4 and 5 are alternate interior. Notice that 3 and 6 are both 55 degrees, and 4 and 5 are both 125 degrees. So we can conclude that alternate interior angles are congruent. Next, let's look at how alternate exterior angles are related when the two lines are parallel that are cut by the transversal. Alternate exterior angles are angles on the outside of the two lines, so angles up here and down here, and they are on different sides of the transversal. So angle 1 and angle 8 would be alternate exterior angles, and the 55-degree angle up here and angle 7 down there would be alternate exterior angles. Notice that 1 and 8 are congruent. They're both 125 degrees, and the 55-degree angle up here is the same as measure of angle 7 down here, 55 degrees. So we can conclude that alternate exterior angles are also congruent. And the last angle pair that we'll look at are consecutive interior angles. Remember, consecutive interior angles are angles on the inside, so we're looking at these in here, and consecutive means that they're on the same side of the transversal, so we're looking at angles 3 and 5 and 4 and 6. This time, they are not congruent. Notice that angle 3 is 55 degrees and angle 5 is 125 degrees. But if I take 125 plus 55, I get 180. Looking at angles 4 and 6, I have 125 and 55, which again, their sum is 180 degrees. Therefore, if two angles add up to 180 degrees, those two angles are supplementary. So consecutive interior angles are supplementary. So just to reiterate, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. So it's really hard for students to remember which one is the supplementary one. And what my suggestion is, just look at the diagram. When you look at the diagram, 4 and 6 do not look like the same size, and 3 and 5 don't look like the same size. Now, I know I've told you not to assume anything from a picture, but that's just the easiest way to remember that they are supplementary and not congruent, is that they literally just are not the same size when you look at the diagram. And just another side note, I would definitely put this down in my notes. Another thing to note here is that these are actually theorems. We know that this statement right here is actually the corresponding angles postulate. However, we can prove that alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. These are all theorems. So if I was going to use that alternate interior angles are congruent in a proof, then my reason would be the alternate interior angle theorem. The same would go for the alternate exterior angles theorem and the consecutive interior angles theorem. Example number 2, find the value of x. Let's first look at what we are given. We know that this angle is 115 degrees. We have angle 4 marked right here. Doesn't really tell us anything, but we have angle 4 marked right there, and we're told that this angle is x plus 5. So let's look at the relationships. If this is 115 degrees up here, angle 4 would have to be 115 degrees, since they are vertical angles. Now look at angle 4, which is now 115 degrees, and the x plus 5 angle. These are consecutive interior angles. We know that consecutive interior angles are supplementary. So I'm going to set up my equation by taking x plus 5 plus 115 and set it equal to 180. Now it's time just to solve it. X plus 5 plus 115 would be x plus 120. I would then subtract 120 from both sides, and I'm left with x equals 60. Example number 3, find the value of x. Let's first look at what we're given. We are given that this angle is 135 degrees, and this angle is x minus 30 degrees. Let's look at their relationship. This angle would be corresponding with this angle, because if I put this line on top of this line, these two angles would be in the same position. We know that corresponding angles are congruent, so I'm not going to add these together and set it equal to 180 like in the last example. I'm going to set them equal to each other. So there's my equation. I would then add 30 to both sides and get x equals 165. Example number 4 has us doing a proof. Prove that if two lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So basically we are proving that alternate interior angles are congruent, just like we figured out a few slides ago. So what we're given is that P is parallel to Q. You can also see that in the diagram. P is parallel to Q marked by these red triangles, and they're cut by the transversal T. We're supposed to prove that angle 1 and angle 2 are congruent. So the first step in the proof is P is parallel to Q. We were given that. Next, angle 1 is congruent to angle 3. How do we know that? If you look at angle 1 and angle 3, they are corresponding angles. Therefore, by the corresponding angle postulate, we would know that angle 1 is congruent to angle 3. Next, angle 3 and angle 2 are congruent. How would I know that? Angle 2 and angle 3 would be congruent because they are vertical angles, and vertical angles are congruent. So I would know that angle 3 and angle 2 are congruent by the vertical angles congruence theorem. And finally, linking all of this together, we would be able to state that angle 1 is congruent to angle 2 because if we look back up to these two statements, we say that angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2. They have angle 3 in common, meaning that angle 1 and angle 2 are congruent, so I would have the transitive property, RST123, 1, 2, 3, so it's the transitive property. And there's our proof. So to show that this proof is done, we would do 2 slashes to indicate that the proof is over. Our last problem is example number 5. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is equal to 40 degrees. What is the measure of angle 1? How do you know? So looking at this diagram, we know that angle 2 is 40 degrees. We are also shown in this diagram that the yellow lines are parallel because they are marked with the little tiny triangles. Therefore, this line would be a transversal, so we are forming alternate interior angles. So if angle 2 is 40 degrees, its alternate interior angle would be 40 degrees, which is angle 1. So the measure of angle 1 would also be 40 degrees because of the alternate interior angle theorem. And see how I abbreviated that. I wrote ALT for alternate, INT for interior, used the angle symbol for angle, and then abbreviated theorem with THM. You can also abbreviate the alternate exterior angle theorem and the consecutive interior angle theorem, and you could even abbreviate the corresponding angle postulate. That's it for this section. Let me know if you have any questions when we cover this in class, and we'll see you then.